Let's humble ourselves and pray. Dear Lord, we thank you for the gift of life. We thank you for your guidance over each and every one of us. We thank you that you've enabled us to move until this point where we are. Lord Father, as we are in a pivotal point, Lord Father, in studying, learning, and understanding what we're going to study today, we pray that, Lord, you may go before us, that you may enable us to understand everything we're going to be taught. May you bless the teacher, and may you enable him to disseminate knowledge, Lord Father, towards us and make us understand. Lord Father, enable us to understand and retain this knowledge, and I pray for excellence at the end of it all. In just his mighty name I pray. Amen.
Thank you so much for the word of prayer. Like I've already informed you in the group, that today our major area of concentration is going to be in line with what we call vector calculus. So that is where we are going to concentrate. That is the area we are going to be looking at. Those who have looked through the past papers, you might have noticed that that is one of the numbers that usually appears in section B. If you have seen numbers of this nature, like the way you see number 10 in applied math, this is what you call vector calculus. And this is one of the numbers that at least each one of you should be able to get 12 out of 12. It doesn't matter which kind of mechanics you have done at your school, because I understand that some schools do not even teach mechanics, but these are some of the numbers that can be easy for any child. In fact, even it can be easy compared to numerical methods and other numbers, because for it, it will take little time as long as you are very good with differentiation and integration, of which the differentiation and integration you apply on such numbers is the basic integration. So it's not something that is very hard. So today we are going to concentrate at that area of vector calculus, and our target is that by the end of this session, at least each one of you should have picked something, and you should be at least ready to do any number that they give you in that area of vector calculus. Now, when we talk about vector calculus, this is a field that is mainly concerned with differentiation and integration. So we are going to be mainly looking at the integration and differentiation. Those are the major things in this particular topic of vector calculus. So we basically look at how do we differentiate and how to integrate. And at this point, I do expect that each one of you, at least you remember your knowledge of integration and differentiation. And we say that when we talk about differentiation, we are looking at breaking things. You break something into smaller particles. That is differentiating. Then integration means bringing small pieces or bring small particles together. So integrating means you bring everything together. Differentiation means you separate. And you know from the differentiation that if I have y is equal to x power n, we know that from our differentiation, this will be dy dx equaling to nx n minus 1. That is from differentiation. But also we know that if it is integration, when I have any function to power n, it means that in order for me, when I integrate my function of y, this one will be able to give us an integral of x power n with respect to the x. So when we integrate, we know that our power increases by 1, and then after you divide by the new power, then plus the constant of integration. So that is the small knowledge on integration and differentiation. So anything we are going to be doing in vector calculus is going to be rotating about how do we differentiate, how do we integrate. It doesn't matter whether you are doing BCM, whether you are doing PCB or, sorry, BCM, any combination as long as it's math. So you don't need to have that background of physics in order for you to do it. Now, in vector calculus, we have some keywords or key terms you are going to get familiar with. And one of the words is distance, speed, and time. So when you look at this side, these quantities are what we call the scalar quantities. Then when you look at this side, these are what we call the vector quantities. Now, what do you need to know is that when I talk about distance, distance is a scalar, and you know that distance means the measurement between any 2 points or the length between any 2 points. Then when I talk about displacement, displacement still is the distance you move. But when it comes to displacement, for it, you must move in a given direction. So the only difference is that with displacement, we consider what we call the direction, that is displacement. Now, here in vector calculus, these two, you must be very careful. Sometimes they may ask you for distance. So when they ask you for distance, you must get the scalar. When they ask for displacement, your answer should be a vector. When it comes to speed, we know that speed or you know that speed is just the measurement of how fast something moves. So speed is a scalar quantity. But when I talk about velocity, velocity is that particular speed, but you move in a given direction. So the question may ask you either speed or velocity. So when they ask you speed, it means that you'll go on and speed. When they ask for speed, you must first obtain velocity, then you get your speed. Then they can as well go on and ask for acceleration. So when it comes to acceleration, acceleration is the velocity that is the velocity in a given direction. So that means you need to be very familiar with those words. So these three keywords are going to be very key: displacement, velocity, and acceleration. And how do we denote them? Now, when it comes to mechanics, when we are denoting distance, it depends. But the major components we usually denote is displacement. So displacement, sometimes we can use S, sometimes they can use R, depending on the question. Then when it comes to velocity, the common one we use is V. When it comes to acceleration, we denote it by A. So when you find A, it means you are looking for acceleration, but also the units will be guiding you because acceleration is given in meters per squared or in meters per second squared, or you can find it written like that. Then velocity is in meters per second, or sometimes they can write it as like this. Then displacement is in meters. Kindly let me know whether we're on the same page through the chat. Are we on the same page? Okay. 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 Daisa said yes, Shiba yes, and King of Diamonds. Okay. Now, that is where we are going to start from. Now, what do we need to know? Now, this is the most important relation I want you to know. This is where the most important relation that I want you to know. But before we reach here, okay, okay, it is well. Now, when we have displacement, I've told you displacement, we denote it with S, sometimes R. Velocity, we denote it by V, and acceleration, we denote it by A. Now, in order for you to obtain velocity, you'll have to go on and differentiate. In order for you to obtain one, to move from displacement to velocity, it means you differentiate what you have as your displacement. To obtain acceleration, acceleration is related to velocity. It means you go on and differentiate your velocity. I don't know whether we are getting where my point. I'm saying that displacement, like I've said, displacement or distance, in order for you to obtain our velocity, we shall go on and have the displacement differentiated. In order for us to obtain our acceleration, we shall go on and differentiate velocity. But where does it come from? I want to remind you that velocity is equal to, or when we are defining what is velocity, velocity is that distance we move in a particular direction. So in your, in senior 4, you used to say, is the change in displacement over change in time. Now, when it comes to change, velocity, the change in displacement, sometimes we represent it by this sign and we put R sometimes, or you can use S, depending, divide by the change in time. Now, the change in S is what translates into what we call the S dt. And this is what we call velocity. So in order for you to obtain velocity, you differentiate displacement. In order for you to obtain acceleration, you differentiate velocity. Members, is that fine? Are we on the same page there? I want to know whether we're on the same page. Okay. Okay. Good. Now, I'm going still to write on the sides because I want you to understand. Now, still, when we have acceleration, acceleration, we shall always say, is the change in velocity out of the change in time. Now, the change in velocity, we can represent it by change in v out of the change in time. Now, what happens that your change in v is what translates into the v dt. And this is what we call our acceleration. Now, these two important things are going to be very important. That velocity is ds. I've said sometimes they can use s or r. And then acceleration is dv dt. Class, are we together on that? Can you write those two formulas somewhere? Because they're going to be very, very important. They're going to be very, very important. When you finish, you let me know.
This one's very 15.
Okay. Okay, now we continue. Now you can now here you are going to allow me to write that velocity will be given by ds dt. Then here I write that acceleration will be given by dv dt. Now to come back, to come back, to come back, in order for me to be able to come back, let me say, to obtain my velocity when I have acceleration, I'm going to use the sides here. That acceleration is given by dv dt. Now, members, when I cross multiply, I'll have dv is equal to a dt. Like when you cross multiply like this. Now, what happens that when you have the v and you want to obtain v, you integrate on both sides. I integrate, I integrate. So mean that my v will equal to the integral of a dt. So whenever I have acceleration and they want me to obtain velocity, I will integrate the acceleration. Members, can you tell me in the chat, what about when we want to obtain displacement and we have velocity? What do we do? Or what do we integrate? Anyone to try to let us know? What do we integrate? Okay, Mutai, were you trying? Okay, I'm not getting Mutai. Okay, now in order for us to obtain, in case you have velocity and you want to obtain displacement, still you do the cross multiplying. So you have your ds is equal to v dt, then you integrate. So your s will equal to the integral of v dt. So that means that to obtain your displacement, you'll have the integral of v dt. So that is what it means. So okay, so class, are we together on that? You can let me know. Yes, J, that was okay. Tamilas, that was okay. Wasenyo, yes. Okay, you let me know when you finish such that we can continue. Oh, I think when you finish, you let me know such that we can continue. Okay, we can continue. Perfect. Now we can look at the first example. They are telling us that given that the r dt is equal to that, find r. Now, always when you meet such questions, you first read it to understand what they want and in which format they want your answer in. After obtaining that, then you are going to go on, and then start off your approach. Now they are telling us that from the question, they have given us our dr dt. So they are telling us that dr dt is equal to 40. I is a direction, which is equivalent to x. J is a direction equivalent to y. And then k is also a direction equivalent to So what do you do? What are we going to do? We want to find R. Like I've told you, here, the best way now you can approach search, it is that you want to obtain your R. So I can remove the T by multiplying by the T on both sides by multiplying by that dt. So what do you have? You're going to have your dr equals to 40I minus T squared J plus TK. Then everything into dt. Now, in order for you to eliminate this dr, it means you must integrate on both sides. So that is what we are going to do. So we are going to integrate this side, integrate. So we shall have r equals to the integral of 40I minus T squared J plus TK dt. Then we start integrating each of those terms separately. So you integrate I alone, this component of I alone, integrate J alone, integrate K alone. But you know very well that there is an hidden one here, there is an hidden one here. And we said that whenever we are integrating, in case this is xn and I'm integrating, we shall always increase the power by 1 and then after divide by the original power. So here we have a 1. So when we integrate, we shall have 4t squared out of 2 in the I direction minus t cubed out of 3 in the j direction plus t squared out of 2k in the k direction, then plus our constant of integration, and that is our r. But we can now continue. This 2 and the 4 can reduce and say by 2, 1, by 2. So we shall have 2t squared I minus t cubed out of 3j plus t squared out of 2k, then plus c. And this is r. Now, in case you want, even you can indicate that these are vectors by you can indicate that these are what? Are vectors. So what do you do in case you want to indicate that these are what? That these are vectors, you put the tilde. So you just put some tilde here to show that these are vectors, something like that. So class, are we together on that?
Yes.
Okay, hope that is okay, class. So that is part A. Because they told you at any time, so you leave it there. Then when you go to part B, they say that if r is equal to 0 at t is equal to 0, so they are telling us that our r is 0 and t is equal to 0. So what do? You substitute the value of r and t in the previous item that we have been dealing with. So now here we shall say r is equal to 2t squared I minus t cubed out of 3j, then plus t squared out of 2k plus c. So we substitute where there is r, put 0, where there is t, put 0. So I have 0 is equal to t times 0 squared I minus 0 cubed out of 3j plus 0 squared out of 2k plus c. So you notice that here I'll have 0, 0 minus 0 plus 0 plus c. And at the end, you'll notice that c is equal to 0. So after obtaining your c, since they want that you'd find the value of r, then you'll come and say, now my r will equal to 2t squared I minus t cubed out of 3j plus t squared out of 2k. And now that is our r. So they wanted us to find what is r when our t is equal to 0. Hope that is very fine to each one of us. In case we are leaving you, you can let us know. You let me know when you finish. In case you have a question, please feel free to ask. When you finished, right, you let me know, and then we continue. Okay, has everyone finished? Are we going to continue? You can let me know. Let me know through the chat whether we can continue. Okay, I think class we can continue. I'm assuming we have finished. Okay, now our second number. This is our second number, and they're telling us that a particle is said to be accelerating at a uniform rate from rest at the origin. Find. Now, the first thing always you have to pay attention, which quantity have they given me? Is it acceleration? Is it velocity? Is it displacement? Because that quantity they have given you is what determines what you are going to be finding. So that one is very, very key. Now you go back. Now you are noticing that here they have given us accelerating, meaning that they have given us acceleration. And how do we obtain acceleration? We know that acceleration is what has been given 2t plus 4, everything meters per second squared. but this is a vector, do not forget. Now, when I go back, I'm going to ask myself, what do they want me to find? They want me to find the velocity. So I go back to what I showed you, that when you want to find velocity, when you have acceleration, this is what you use. You integrate the acceleration. So I'm going to come back here. In other terms, for you have to remember that when you start with displacement, which is S, you go to velocity, then you go to acceleration. So to move from acceleration to velocity, to go up, I am going to be integrating. To come down, I'm going to be differentiating. So we are going from acceleration to velocity, so I'm going to be integrating. So mean that our part A, in order for us to obtain velocity, we shall say that velocity is equal to the integral of A with respect to time. So time here is a variable. It keeps on changing. Now we shall have V equaling to the integral of 2t plus 4, then everything with respect to t. Then you start integrating each component. So the first one, we shall integrate and have t squared out of 2 plus the 4t, then plus a constant, and this is equal to the velocity. Now, what do you take note of? That these 2 and these 2 are going to reduce. So your velocity will equal to t squared plus 4t, then plus a constant. But what did the question tell us? The question wanted us to find the time at 3 seconds. But they told us that from this particle was moving from rest at the origin. So what you ask yourself, at rest, at the origin, meaning that its initial time t is going to be 0. And since it was at rest, we know that its initial velocity, we call u, is going to be also 0. So meaning we are going to come and say v is equal to t squared plus 4t plus c. So our initial velocity, which is v, which happens when t is equal to 0, we are going to substance say this is 0 equals to 0 squared plus 4 times 0 plus c. Now, after that, it means we shall have 0 equaling to 0 plus c, and therefore our c will equal to 0. So mean that the constant of integration c is equal to 0. And therefore you conclude that my v, my velocity, is equal to now t squared plus 4t, because the c is 0. Now from there they told us, but they want the time after 3 seconds. Now you say, after our 3 seconds. So where there is t, you're going to substitute the 3 seconds. So velocity will equal to 3 squared plus 4 times 3. This will give us 3 squared, which is 9, plus the 12. Hope members, we have that. Then 9 plus the 12, it will give us 21. So we shall have this as 21, but velocity is given in meters per second. And that is our velocity. Class, are we together? Are we on the same page? You can let me know through the chat whether we're on the same page. Okay, people are saying we're on the same page. Okay, we can first write, then we move on. Oh, Infinix, why do we use velocity is equal to 0? Now, velocity, remember, is the speed you start with. Now, when you are at rest, it means you are not moving. You are not going anywhere. So if you are at rest in one position, you are not moving. It means that your initial velocity is 0. I don't know that Infinix, we are together. Infinix, you can unmute and let us know. Are we on the same page? Yes. Since you are not moving, that's why our initial velocity is 0. They told us is at rest. At rest means you are there seated in one place. You are not moving. So we can't say you have a speed. Okay. When you finish, you let me know, and then we continue. Okay. Daisy, you can unmute.
Teacher, good
Mm.
afternoon.
Good afternoon.
My question is like, why do we use like that t equals to 0 and okay, no, that v equals to 0 I get, but like,
Mm.
can't we use, why don't we use like the 3 seconds, like
Oh,
first?
yeah. Okay. Now, our first intention, Daisy, is to first find what is C. Now, this C
Oh,
is like the constant of integration. So that should always be your target to first eliminate. From your equation, you have formulated. Now, in order for you to eliminate that C, you use the initial conditions. And from the initial conditions we had, they told us that this particle was at rest. So when something is at rest, what does it mean? It means you are not moving. And they said you are at the origin. So that means that initially the time was 0. When they started counting or when they put on the timer, they counted up to 3 seconds. It's like when a car is moving. Initially, you are in one place. So here we shall say t is equal to 0. Now, when you start moving, we start counting. So from the initial point up to where you are is where we have the 3 seconds. So now the 3 seconds, the velocity, we substitute after us eliminating the C.
oh, okay. Thank you.
Okay. Otherwise, when you substitute when there is C, when you'll find that you have like, you're going to have C as a constant there.
Okay, thank you.
Okay. I think, are we good to continue class? Okay. Now we go to the next one. The next one wants us to find the distance traveled at t equals to 2 seconds. You come back, you ask yourself, distance, I want you to take note. There is something we call displacement and we call distance. This S stands for displacement, but there is no any way you'll get distance minus you getting displacement. So the first thing you do, you first obtain your displacement. And we have said when we are going down, to get displacement from velocity, we shall also integrate. So what does it mean? Our velocity we got, this was our velocity, which is t squared 40. So, oh, okay. Allow me to, okay. Let me, okay. Let me create another slide here to be able to, okay. Now, we have our velocity already. We have obtained our velocity as t squared plus 40, and this one is in meters per second. Now, in order for us to obtain the displacement, which we can call S, we say that displacement will equal to the integral of v dt. Now we start. We shall have integral of t squared plus 40 everything dt. Can we have someone to integrate for us? Who wants to integrate for us? You can raise up your hand or you can unmute and you integrate for us. Yes, Daisy, you can integrate for us.
It will be t cubed out of 3
out of 3.
plus 4t squared
Mm-hmm.
out of 2
Okay, out of 2.
plus
Then plus C. Good. Now this is the displacement. Now, since you can reduce this by 2, 1 by 2, 2, we can reduce that. So we shall have t cubed out of 3 plus 2t squared, then plus C. Now, the first thing we do, always we eliminate the C. Now, initially, we say at initial, because they told you that this particle was initial at rest. It means that the time was 0. Then if you are at the origin, what is your displacement? What is the distance? Now, if the particle is still at the origin, it means that also the initial distance is going to be 0 because you have not moved anywhere. But however, here I want you to understand why we are equating S equals to 0, because they told us that our particle was at the origin. And we know that origin is 0, 0. So it had not moved in any direction. So that's why we shall take our displacement initially as 0. So what does it mean? It means that our S will equal to t cubed out of 3 plus 2t squared plus C. So we substitute. S is 0. This is 0 cubed out of 3 plus 2 times 0 squared plus C. And you'll notice that everything will end up having 0. So mean that our displacement after any given time is given by t cubed out of 3 plus 2t squared, because this C is now 0. Now, this is the displacement of the particle at any time. But they asked us to find what about after 2 seconds? Now, after 2 seconds, what are we going to do? We shall come and say, at t equals to 2 seconds, what do we have? So we shall say S is equal to 2 cubed out of 3 plus 2 times 2 squared. So here we shall say 2 cubed is 8 out of 3 plus, this is 4 times 2, which is 8, meaning that our S will equal to, so you can compute that plus 8. This is about 10.6667. And now this we just say meters. But I want now to re-echo. We are lucky that here we had just one direction. Our particle was moving in one direction. And therefore, our distance here, we cannot continue. So your distance, for this case, if a particle is moving in one direction, still will remain 10.667 meters. But please take note, if, let me say, our particle was moving in more than one direction, what does it mean? You would have remained with your displacement as something like this. This is just an example. You would have remained with something like that, maybe K. In order for you to obtain your distance, it means you'll come and get the magnitude of your displacement. So distance is given by the magnitude of the displacement. So you would have just come and say 2 squared plus 3 squared plus 4 squared, and then you get the answer. That is the meaning, if our vector was in more than one direction. Yes, hope class we are on the same page. When you finish, you let me know. When you finish, you let me know. Okay, someone has finished. Can we have one more person to let us know that we can continue? Okay, I think we are good to continue. Okay. Okay, we have another one. They're telling us that we have a particle moving with a velocity. We have this particle moving with, this is with a velocity of that is accelerated uniformly at the rate of this. Find the speed reached by the particle. Distance traveled by the particle. Now, what do you notice? Here they have given us two things. They have given us the velocity, which is 2I plus 3J. They have given us the acceleration, which is 3Ti minus 2J. But they're asking us, what is the speed reached by the particle at t equals to 4 seconds? So for you, first write your side work that we have displacement, we have velocity, and we have acceleration. Now, in order for me to obtain speed, I will need to have velocity. So what does it mean? It means when I have acceleration, I can integrate it to obtain my velocity. So that is the first thing you need to have at the back of your mind. So that is where we are going to start from. But remember, the velocity they gave you, that is the velocity the particle was moving with initially. That is the meaning. So you need to pay attention to it. That initially, when the particle was moving, it was moving with that kind of velocity. Hope that is okay. So what does it mean? It means we shall say that velocity is equal to acceleration A dt. That is the meaning. Now, what does it mean? It means that now I'm going to go on and obtain my velocity. So velocity will equal to the integral of 3ti minus 2j, but everything times the t. From that point, you start integrating. Remember, you have t, you integrate it. So we shall have 3t squared out of 2i minus 2tj, then plus a constant, and this is equal to our velocity. Now, from that point, you're going to go on and ask yourself, they want me to obtain speed. But when initially, when this particle was moving, initially, it means that your time will equal to 0. But initially, this particle was moving with a velocity of 2i plus 3j. That is the meaning initially. What does it mean? We are going to come here in our equation we have formulated. Where there is time, we shall put 0. Where we have velocity, we shall put 2i plus 3j. So how is it going to look like? I'm going to substitute where there is v. This is, sometimes we can call this v when t is equal to 0. Is equal to 3t squared I minus 2tj plus c. So here we shall have 2i plus 3j is equal to 3 out of 2 times 0 squared I minus 2 times 0j plus c. Clearly, you'll see that this side will remain with the c, and this side we shall have 2i plus 3j, and that is our vector c. When you put it on a graph, I can just demonstrate it. It is something like this. This is your velocity, and this is like your time. But the initial velocity is somewhere here. But you know that when you are calculating, this is time like 0, 1, 2, 3, and this is 4. So what we are trying to find, we are trying to find the speed when the particle was, when t is equal to 4. But in order for us to obtain it, we start from here. When the time was 0, this particle had a velocity of roughly 2I plus 3j. So this is like the rough graphical representation of what we are doing. That when the time is 0, the particle was already above the origin with a velocity of 2I plus 3j. That is the velocity it was moving with. So when I come back here, friends, I'll have V is equal to 3 out of 2 t squared I minus 2tj. Then where there is C, I'll put 2I plus 3j. Now, after doing so, we collect like terms. You bring your j's together, you bring your i's together. So this is I and I, this is j, and this is j. So we shall bring them together, and I'll have here, I'll have, if you want, you can bring them first together because you'll need that equation in the next part. So I'll say V is equal to 3 out of 2 t squared plus 2 everything into I. Then I'll have minus. Here I can have minus, or you can say plus. Then you say negative 2t plus 3 everything into j. And now that is our velocity at any time. Class, let me know whether we're on the same page. Kindly let me know whether we are on that page. Are we on the same page? Where are you lost? Where are we lost?
Thank you.
Okay, I think we can continue. Yes, Daisy, you can unmute.
Teacher, I was asking, like, is the acceleration always initially 0, even if it's not mentioned?
No, sometimes no, acceleration may not necessarily be 0. Yes. Acceleration is the speed you move with.
Yeah.
So it is only 0 at the start, but the moment you start moving, there is some acceleration.
Okay, and also like when they don't mention like specifically, is there like the time is always gonna be 0?
Time. Okay, now you look at the wording, how they have put the wording. That initially, or you reason basing on the question.
Oh, like not specifically this question.
Yes. Yeah. So it depends on how the question is being set.
Okay.
Yes, it can be initially, but when they started timing, take an example, like when you look at this graph roughly, they may tell you the velocity when t was 1, the velocity was this. So for that one, you can't start from there. Fine?
Thank
Okay.
you.
Now we substitute. Yes, Chebet? Can unmute? Chebet?
Yes, I just wanted to answer her.
Okay.
I wanted to say that acceleration will be 0 if the velocity is not changing. So if they say they are moving, the particle is moving with a constant velocity, that means acceleration is 0 because velocity is not changing. In case velocity is changing, then acceleration will not be 0. If the velocity is keeping on increasing, acceleration will be positive. It keeps on decreasing, then acceleration will be negative or called retardation. Thank you.
Okay. Thank you, Chebet. Yes, so that is what happens. And for those graphs where velocity is 0, sorry, where acceleration is 0, is when you have a flat line like this, when velocity is constant at one point. Okay. Okay, now we are going to continue. So when it is equal to 4 seconds, you substitute. So we shall say V at t equals to 4 seconds. So you substitute. So this will be 3 out of 2 times the 4 squared plus the 2I, then plus negative 2 times 4 plus 3, everything into G. You're going to make your calculations here. I'm going to make mine as well. So here I'm ending up with 24I. And here I'm ending up with negative 5G. So you're going to just confirm your answer. But when you look at this question, they wanted us to find the speed. Now, since they have told us to find the speed, what we have currently is velocity, and these are meters per second. So in order for us to obtain speed from velocity, it means we must get the magnitude. So that is what we are going to get. So, okay, I think I had space. So we are going to obtain the magnitude. So we are going to come and say, sorry. We are going to come and say that now our velocity, we have obtained our answer. I think it was 26, 24. Hope that is what we have. Kindly just confirm. Okay, let me confirm again. No, this is 26. We have to add on the 2. I had forgotten to add the 2 because 3 out of 2 times 16, this is by 2, 1. 16 by 2, that is 8. 8 times 3, that is 24. So here, this is 24 plus the 2, which gives us 26. Okay. Now, our velocity will equal to 26 of I minus the 5 of G. So in order for you to obtain speed, always please do not forget that speed is always given by the magnitude of velocity. So we shall come here and say, now the magnitude is going to be 26 squared plus negative 5 squared. It's like when you have your, now this speed, if at all I'm putting it like on the, let me just demonstrate on the diagram. So it will be like, this is something like this. Whereby this is where you have your 26 and this is where you have your 5. So that is the velocity, that is the pictorial representation. So speed is just this line here that you are trying. So to obtain it, you use the Pythagoras theorem. So that's why we just say this. So here, when you 26 squared will give us 676 plus 5 squared, which will be our 25. So when you add, you'll end up with 701, and the square root of 701 will be our answer as 26.4764, and these are meters per second. So that's how you obtain your speed. Okay. Hope that is okay, members. Okay. Hope that is fine. In case you're getting some challenge, you can let us know. Well, to how many DPs? At least 4. 4 are good enough. Oh, I first go back to the slide with the question. Okay. Okay. When you finish, you let me know. Okay, I think we are good to continue. Okay, now the next one, they're asking us to find the distance traveled. So in order for us to find a distance, it means we are going to first find our displacement. And how are we going to find our displacement? One, the good thing, we already have the velocity at any time. So our velocity at any time, which we can write like that, we had it as, when I go back a bit, it is this one here, fill it 2, 3 out of 2, t squared plus, I think 2, everything into I, then minus 2t plus 3 plus minus 2t plus 3g. Yes, so that was our velocity at any time. So to find our displacement, we shall say that displacement is equal to the integral of v dt. So we are going to integrate this. So we shall now have our integral. You can in fact first put t into 3 out of 2 t squared plus 2I plus negative 2t plus 3j with respect to time. So when I integrate, that one is going to be 3 out of 2 t cubed out of 3 plus 2t. This is just the I component plus negative 2 squared out of 2 plus 3t into the j component plus the constant of integration. Now from here, you can reduce a bit. So the first one, we shall remain with t cubed out of 2 plus 2t, everything into the I component. Then the next one, we shall have plus negative t squared plus 3t, everything into the j component plus c. Now you go back to the question. What happened? That initially at t, the initial distance the particle had, when time was 0, what was that distance? What was the displacement? Was there any displacement or it was 0? Now, you can go back and first read the question and see, was there any displacement or no? Because at time is equal to 0, it means the particle has not yet started moving. It is at rest. So mean that your S will equal to 0. So where there is time, you'll put 0. Where there is S, you put 0. So you'll find out that our C will also equal to 0. When you substitute, but you first substitute first members, you say 0 is equal to 0 cubed out of 2 plus 2 times 0. This is I plus negative 0 squared plus 3 times 0j plus c. So you'll end up with your c is equal to 0. So that is the first thing you do. Now from there, I'm going to come and say that now my S, since c is equal to 0, it means that our S will equal to q cubed out of 2 plus 2t, everything into I, plus negative t squared plus 3t j, then these are meters. Now, but they told us that they want the distance when t is equal to 2. So we first find the displacement. For t equals to 2 seconds, so we substitute. So we shall have s into 2 cubed out of 2 plus 2 times 2 I plus negative 2 squared plus 3 times 2 j. Now, this one will give us, this one is going to give us 2 cubed, that is 2 times 2 times 2, which is 8 out of 3 plus 4, everything into I, plus this is going to be negative 4 plus 6j. So 8 out of 3 plus 4 will yield 20 out of 3. So here we shall have 20 out of 3 of I. I don't know whether we're on the same page. Then plus negative 4 plus 6, which will be 2j. And this is our S. Class, are we still on the same page? You can let me go through the chart whether we are still on the same page. Okay, yes, ZTE, you can unmute.
Well, I just wanted some little clarity.
Okay.
Is it mainly for every maybe calculation we go through, like if you're looking for velocity and speed, maybe at a certain time, does it imply we have to get its initial points?
Yes, that initial, like you have to eliminate that C. Have you
Okay.
seen this? Yes?
Yes, I've seen it.
Yes. So always your first task is to ensure that C is out of the equation.
Okay. All right, thank you.
Okay. Oh. I think we can continue. We can continue. Okay. Now, when we reach here, since we want to get distance, we say that distance will equal to magnitude of displacement. And we said, how do we obtain? This will be the root of 20 out of 3 squared plus 2 squared. So members, you can obtain your distance. Compute that and see what you get. On my end, this is what I'm getting. So just confirm whether you also get the same or my answer is different from yours. So you can confirm whether your answer is...
Yeah.
Are the answers the same or mine is different? Do we have the same answer or it is different? Oh, it is 8. Not the same. Ocheng, that's 8 out of 2. 8. Oh. I'm not getting you. Can you come again? I don't know. People are saying it is 8 out of... Okay. First let me... Yes, Douglas. Oh. I think I've
Yes,
seen.
sir. Good evening.
Good evening.
Yeah,
I think
there.
here,
There
this
was
is...
where I wanted to tell you that
This was 2. Okay.
Yeah. But the only thing is to
Okay, it
after
is 2.
substituting in.
Okay, thank you. Okay. So now I'm getting 8.2. Do we have the same now? Okay. Hope we have the same now. Okay. Okay. Please now check, confirm that you have that. Okay. I think now we're on the same page. We have the same. I think there was an error here. I think I had taken it as 3, yet it was 2. Okay, but thank you for the correction. Yeah. It is 16, not 8. Really? because 2 cubed means 2 times 2 times 2, which is 4 times 2, which is 8. Phoenix, can you check and see? When you finish, you let me know. Okay, I think we can move on. Okay, now we'll go to the next one. Okay, now I've tried to pick some UNEB numbers that we are going to try out. And this is the number. So they're telling us that a particle of mass 4 kilograms is initially at rest. So you keep taking note of those words, is initially at rest at the point 2 negative 23 meters. Now, this particle may be at rest, but where the particle is, it means that this particle, the position where it is placed, is the position above the origin. So when you are letting for your distance, that time is equal to 0. Here it means that its initial displacement is not going to be 0, 0, 0. No, it's going to be 2, negative 2, and 3 meters. Now, what else do you need to know? That when they give you force, you need to ask yourself, how do I obtain acceleration? So you need to remember your Newton's laws of motion. So we are going to start from there. Now, the first thing I want to bring to your attention is the part A. And here we shall employ the Newton's law of motion, which tells us that force is always given by ma, whereby F stands for force, M stands for mass, and A stands for acceleration. And what do they want us here to obtain? They want us to obtain acceleration, meaning that to obtain acceleration, you must make A the subject, so you divide by m, meaning that your acceleration is given by force out of the mass. That is the meaning. But do not forget that acceleration is a vector quantity and force is a vector quantity. So we are going to obtain our acceleration. So we shall say that sometimes you can use that tool. Acceleration will equal to force out of the mass. So our force is given by 40 t squared 5. And we are going to divide this by the mass, which is given as 4. Now, in vectors, when we are dividing, this 4 affects each. Sometimes you can even write this as 1 out of 4 into 40 t squared and 5. So we are going to divide. So when I'm dividing, I'll have 40 divided by 4. I have t squared divided by 4. I have 5 divided by 4. Because that divides each component. So that means that our acceleration will equal, for the first one, we shall remain with only t. For the second one, we shall remain with t squared out of 4. Then at the last one, we shall remain with 5 out of 4. And what is this? This acceleration, meaning meters per second squared. Alternatively, if you want, you can place and put them in points. That one is also very fine. So another one can give his answer as t 0.25 t squared. Then this is 1.25 and everything meters per second squared. But please take note, in case you place your decimal, your fraction, and is giving a recurring decimal, always better you leave your answer as in a fraction form, because when you have decimals, you are going to divert away from the accurate or from the accurate answer. Class, are we together on that for part A?
Yes.
Yes, okay. Now we go to the second part. Second part wants us to find the speed of the particle after 3 seconds. Now, what do you remember? We have said that whenever you have acceleration, remember we said distance or displacement, we have velocity and we have our acceleration. So when you have acceleration and you want to get velocity, you integrate. So that means we are going to integrate velocity. You are going to integrate our acceleration to obtain our velocity. So I'll come here and now I say for part B, we need the speed. So we know that velocity is going to be given by the integral of our acceleration dt. But do we have our acceleration? That yes. So our acceleration, you will allow me, I will use fractions. It is given by t. Then the second component I have for the acceleration is t squared 4. Then the third component I have is 5 out of 4. Now, when you look at this component of ours, we are going to write it in a horizontal way or in a vector form. Now, in the vector form, we can write this as ti plus t squared out of 4j, then plus 5 out of 4k. And this one is our dt. So we have transformed from this vertical format, the way it was given, into the horizontal format. Then from here, we are going to from here, we are going to go on and now integrate. So the first one, we shall have t squared out of 2i plus the second one, we shall have t cubed out of 3, but we have a 4. So it will be 4 times 3 j plus 5 out of 4 t k, then plus a constant. And that one is going to be our velocity. Now, from there, we can now continue and say this is t squared out of 2I plus t cubed out of the 12j plus 5 out of 40k plus c. Now, you start the conditions. What are the conditions? You ask yourself. Initially, because they told the particle was initially at rest. Now, at rest, did it possess any velocity? That no. Then I'm going to come and I say, at t equals to 0, it means that our velocity, our initial velocity is also going to be 0. So now you substitute where there is v, it's like the initial velocity will be 0. So I'll say 0 is equal. You substitute, you show that you are substituting I plus 0 cubed out of 12j plus 5 out of 4 times 0k, then plus c. So here we shall have 0 equals to c. Now from there, we shall go back and say now our velocity, which is the vector, will equal to t squared out of 2I plus t cubed out of the 12j plus 5 out of 40k, because we have finished to substitute. Now, what did the question want us? They wanted us to find the speed after 3 seconds, but we have velocity. Then you say at t equals to 3 seconds, what will be our velocity? So I'll say velocity will equal to now 3 squared out of 2I plus 3 cubed out of the 12j plus 5 out of 4 times 3k. So this will give us, this is 9 out of 2I plus 3 cubed, which is 27 out of the 12j plus 5 times 3, that is 15 out of 4k. But what are we interested in? So here, if you want, you can put your meters per second. So what do we want? We want to find the velocity. But what did we say now? In case these fractions can be written in decimal points, it is okay. So 9 out of 2, that is 4.5. But I've said if you find that that decimal is a recurring one, better you leave it as a fraction. So this will be 3.75k. Now, what are you going to find? You're going to find the speed. So we say that speed is always obtained by the magnitude of velocity. So we are going to obtain our magnitude. Okay, I don't know that I can squeeze it here a bit. So the magnitude will be 4.5 squared plus 2.25 squared plus 3.75 squared. So members, kindly confirm that your speed, I want to confirm also from my side, confirm and get what your speed is. So, but I'm getting the square root of 39.375. And my answer will be 6.27. 6.27 495. Yeah. So in simple terms, I'm getting my speed as 6.27495. And these are going to be meters per second. Members, are we on the same page? You kindly let me know. How part B? Oh, Timothy, for part B, to obtain speed, you first obtain velocity. Then from velocity, you obtain the speed because speed is equal to the magnitude of velocity. So the first thing you obtain, first obtain your velocity. Then from there, you can go on and obtain your speed. Timothy, we're on the same page now. Okay. Are we on the same page, class? Such that we can continue. Okay. Yeah. Okay, now the last part is where the last part is asking us to find a displacement. But displacement means the distance you move in a particular direction after the 3 seconds. So what are we going to do? We are going to come and say displacement of the particle. How is it obtained? So I told you already that displacement is going to be given by the integral of what we have as our velocity with respect to what? With respect to time. So we say displacement, we can denote it by S, you can denote it by R. So here you can say displacement S, and then you say S will equal to the integral of V dt. So that is where we can now start from. Now, we remember that our velocity initially from our previous number, our velocity, we had remained with 4.5 I. I don't know that I can use this, or I use this one here, this one here. I don't know which one will favor you, but we can use, but remember, you must use that one before you substitute your time. So we are going to use the first one at any time. This is the velocity at any time. So it is t squared out of 2I plus, plus t cubed out of the 12j, then 5 out of 4 plus 5 out of 40k. And these are meters per second. Now, this is our velocity. And the one we are going to use here, remember these are directions, so you can put that tilde there. Here. Now, we are going to say now our displacement will equal to the integral of t squared out of 2I plus t cubed out of the 12j plus 5 out of 4 tk, then everything times our dt. Now, what are we going to do? We are going to integrate. So when we integrate I, members, we shall have t cubed out of, remember there is a 2 there, then times the 3. This is the I plus, this will be t power 4 out of the 12 times the 4. Then plus, so but this is the j direction. Then plus 5 out of 4, this is going to be squared out of 2k, then plus a constant, and this is the displacement. So when we multiply, we shall have t cubed out of, this is going to be 6I plus, this is going to be t power 4 out of, that is 8 4, and this is in the j direction, then plus 5 out of, this is 8, t squared k plus c, and this is the displacement. Class, are we together? Are we still together on that point? Let me know whether we are still on the same page. Are we still on the same page? We shouldn't leave you behind. Okay, yes. Now, initially, I want us to go back to the question. a particle of mass is initially at rest at the point A, tan, tan. Now, this point here is the initial displacement of the particle. So I expect us or you to come and say, initially, when our t is equal to 0, the initial displacement S at t equals to 0 is going to be, now, I'm going to write this coordinate of 2, -2, and 3. 2, -2, and 3. 2i -2j plus 3k. I'm transforming this coordinate A of 2, -2, and 3, 2, -2, and 3 into a vector. So this is what it means. So when I say, when t is equal to 0, where there is S, we shall substitute this. So I will say 2i minus 2j plus 3k will equal to 0 cubed I plus, oh, sorry, here there was 6, I think, yeah. 2 cubed out of 6 plus 0 power 4 out of 48. This is the j plus 5 out of 8. This is 0 squared k, then plus c. Then it means that we shall remain with 2i minus 2j plus 3k equals to c, because the I component will go to 0, j component will go to 0, and this one will go to 0. Then from that point, we are going to go back and say, now what is our S? We come back here, and then we shall say now our vector S will equal to t cubed out of 6i plus t power 4 out of 48 j plus 5 out of 8t squared k plus c. But our c is going to be now 2i minus 2j plus 3k. Now, as a student, you can now collect like terms I and I, j and j, then k and k. So I'm going to come and say this cubed out of 6i plus the 2i. I first bring them together, plus t power 4 out of 48j minus the 2j, then plus 5 out of 8t squared k plus the 3k. I first bring them together. Then from this point, you are going to go, you can factorize out your i's and write this as s cubed into t cubed out of 6 plus 2, everything into I, plus t power 4 out of 48 minus 2, everything into j, plus 5 out of 8 t squared plus 3, everything into k. And then after, you can say everything here is in meters. But what is our interest? Our interest is to find out displacement of the particle after 3 seconds. So we are going to say, now, when t is equal to 3 seconds, so you substitute. So we shall say S is equal to, we are going to put the thing there. So this is going to be 3 cubed out of 6 plus 2i plus, this is 3 power 4 out of 48 minus 2j plus, this is going to be 5 out of 8 times, this is 3 squared plus 3 into k. So we are going to make our computation. I don't know that I still have, I am having another blank page. Let me create another from there. Yeah, but from here, I don't know that I can carry this. Yeah, I want us to carry that to the next slide, hoping we are still on the same page. Now, when I come to the next slide, remember we have, sorry, our S was 3 cubed out of 6 plus 2, and this was I, plus the next one was 3 power 4 out of 48 minus 2. This was J, plus 5 out of 8 times 3 squared plus 3. And this was K, hoping that was the thing. Now, you place your calculator. There's no problem. So you say 3 power 3 divided by 6 plus 2. And according to my answer, I'm ending up with 13 out of 2i. Then plus, you say 3 power 4 divide by 48 minus 2, and I'm ending up with here negative 5 out of 16 j, then plus 3 I think squared times 5 divide by 8, then plus 3. So I'm ending up with 69 out of 8. And this is my K. So I can just conclude and say my answer is 13 out of 2i. Sorry, here instead of writing a plus, since it is a minus, then ignore and say this is minus 5 out of 16j, then plus 69 out of 8k. And then you're going to write everything here in meters. Yeah, so that is how you handle such a part. When they ask you, to find the distance, then you go on and you get the magnitude. But since here they didn't ask, then it is very okay. Okay, so I can take back to the first part. Here I know some of you might be making some write-up. So you can first make some write-up. When you finish, you let Okay, I think some of you have finished. Okay, we can just give 2 minutes. Okay, I think we are good to continue. So for such numbers, please, whenever you find them, you're going to just work out with your integration, differentiation, and then things will come out. But also, sometimes they mix them with the trigonometry. So meaning you must have the idea on how to deal with them when they have given you in terms of trigonometry. So what does it mean? It requires you to have it requires you to have that knowledge of what? Of of trigonometry if you are to go and pass these numbers. Like when you look at the number we have at hand, they're telling us that we have a particle of mass 3 kilograms is moving on the curve described by that, where r is the position vector of the particle. Like I told you earlier on that sometimes sometimes they can give you in terms of R. Other times you may find them using R. Sometimes they use S. But for whatever letter they use, as long as they have described it, that this one represents that, this one represents that, then for you as a student, you must just go and work with what you have. So currently we have our R. Now, what next? You need to know. We said we have our displacement. From displacement, we said we go to velocity, and then from velocity, we shall go to our acceleration. Then you ask yourself, what do you need? They want me to find a position and the velocity of the particle at time t is equal to 0. So what do you need? You are going to ask ourselves, we have the displacement, but do I have the velocity? That not yet. And they told that the position vector of the particle. Now, what are you going to do? You're going to come and say that if I have displacement and I want velocity, when we are moving downwards, we say that always we do the differentiation. So meaning that for this one, in order for us to get velocity, we shall go on and differentiate. If you don't remember it, do not cram. Know that velocity is given by, even you can, those who remember, you remember we said that distance is speed times time some time back. And we said that in order for us to get speed, speed is given by distance out of time. In case that one is failing, come back and say, when I have this is distance, this is speed, and this is time. So you tell yourself that when I want speed, I will set distance out of time. Now here, instead, you relate it very well. You say speed goes with velocity. Displacement or distance goes with displacement. And then I'll have what? My time. So you know that this is, to get velocity, I'll have the r, the t. Something like that. So you can recall it from there. That velocity, we shall have the r, then we have our dt. Hope that is very, very okay. Now we go to the first part. They want us to determine the position when time t is equal to 0. So I'll come and I first get the position. Roman 1, this is r is given by 4 sine 3t I plus 8 cos 3t of g. Now you say at t equals to 0 seconds, you substitute. What is your position? So this will be 4 sine 3 times 0I plus 8 cos 3 times 0 g. So this will be 4 sine 3 times 0, that is sine of 0 I plus 8 cos of 0 g. Then you place your calculator. Here, please avoid assuming sine of 0. That one I know you can be knowing that sine of 0 is 0. So here we shall get 0I plus cos of 0 is 1. So we have 8 times 1g. So we shall end up with 8g. And that is our position. Do not assume, members, because you may make a mistake and say, that one is 0, 0. No, first place your calculator. And these are meters. So that is our position at time t is equal to 0. Then we go to velocity. We have said that velocity is given by the r dt. Now, what are we going to have? We have our r. Now we are going to differentiate it. So we shall say v is equal to d dt of our r, which is 4 sine 3ti plus 8 cos 3tj. Now you need to remember how to differentiate trigonometric functions. Kindly let me know in the chat whether you know how to differentiate or we need to recap it. How to differentiate trigonometric functions. Say, repeat. We need to repeat. You can maybe say R. Just say R if you think we need to repeat, or I just differentiate and we continue. Okay, someone says recap. Okay. Okay, now I'm going to go on the next slide. Oh, sorry. Allow me to create another slide such that I can first recap how to differentiate the trigonometric function. I'm going to use this space here. Now, when we have a trigonometric function, say y is equal to sine x, sine t. Whenever you differentiate sine, you get cos. So dy dt will equal to cos of t. Then when I have y is equal to cos of t, when I differentiate cos, I get a negative. So dy dt will equal to negative sine of t. Now that is the first step you need to remember whenever you are differentiating. Now, after remembering that, when I have y is equal to sine of 3t, what do you need to remember? You need to remember your chain rule. The angle here is what you differentiate. So you take it as one thing. So you remember, you are going to let me know, use this as u. So I'm going to first say, let my u equals to 3t. So when I differentiate here, I'll have the u dt, which will give me a 3. Then my original one will be y is equal to sine of u. And we know that whenever I differentiate the y du, I'll end up with cos of u. And therefore, to get my dy dt, I'll have to get dy du times my du dt. So my dy du is cos of u, then times du dt, which is 3. So mean that my dy dt, I'll write it as 3 cos of u. But my u, we said, is 3t. So it will be 3 cos of 3t. In simple terms now, whenever you are differentiating, let me say y is equal to sine of 5t. What do? Differentiate the angle 5t. When you differentiate, what do you get? You get 5. Then after, differentiate the sine. I will get cos, then write the original angle. And that will be your dy dt. I repeat, when I have y is equal to, let me say, sine of 7t, even if it is squared, it is okay. I'm going to first differentiate this 7t. When I differentiate 7t with respect to time, I'll have 7. Then differentiate sine, you'll get cos. Then write the original angle. Now, to check whether we're on the same page, I want to test. Differentiate for me sine 3t and put your answer in the chat. What shall we have to check whether we have understood? Differentiate sine 3t only. You have said first differentiate the angle, which is 3. Very good. Yes. But you have forgotten to differentiate sine Demetrius. You have forgotten to differentiate sine now. So here, class, we shall have our 4 first. Then I differentiate what is inside. I'll have 3 cos of 3t. Then I. Then plus. I first put the 8 out. I differentiate the angle. I'll have 3. But we have said when we are differentiating cos, we get negative. So I'll have negative of sine of 3t. and this will be my G. So in simple terms, I remain with 12 of cos of 3ti, then 8 times negative 3. That one will give us negative 24 of sine of 3t J, and that is our V. Now, since they wanted at t equals to 0, you will substitute t equals to 0. Now, when at t equals to 0, we shall substitute and say V will equal to 12 cos of 3 times 0i minus 24 sine 3 times 0 of J. So I'm going to write here, this one will vanish, and members, I'll remain with my answer as 12, that is going to be 12i. 12i, and these ones are going to be meters per second. So your answer will be 12i meters per second, and that is your velocity. Hope we are on the same page. Okay. Yeah, that is correct, members. So that is how you obtain your velocity. Okay. Now the next part, they asked us to show that the force, acting on a particle is negative 27. Yes, R. Now, what do you need to know? You need to know what is the force. Number 2, you need to know how is force obtained. That force, okay. We know that force is obtained by mass times acceleration. But do we have acceleration? No. Then you know that acceleration, you come back. We say that we start with displacement, we go to velocity, then we go to acceleration. When you are coming down, we always differentiate. So since we have velocity, we can obtain acceleration. So mean that acceleration is given by the velocity differentiated with respect to time. But do we have our velocity? Our velocity is here, 12 cos 3t. So velocity is 12 cos 3ti minus 24 minus 24 sine 3t j. That is our velocity. So we are going to differentiate. So we shall say d dt of 12 cos 3ti minus 24 sine of 3t j. Now, when we differentiate, we said we are going to differentiate what is inside. You can even first do some cos 3t. When I differentiate, I first differentiate the angle, which is 3. Differentiate cos, which will give me a negative sine of 3t. When I have sine of 3t and I'm differentiating, I first differentiate this, which is 3. Sine, when you differentiate, it is cos, then write the original angle. So members, here we shall have 12 times negative 3 of sine of 3ti. Then here I'll have minus 24 times the 3 cos of 3t of j. So when I continue, I'll have 12 times negative 3, which will give us negative 36 sine of 3ti, minus 24 times 3, that is what, 72. And here I have cos of 3tj. Now, but what did this is acceleration. The question wanted us to show that our force is given by negative 27 of r. Remember, r is the initial displacement. Now, when I come back here, I'm going to say that my force is ma. So what is our m? Our mass from the question was 3 kilograms. So I'm going to come back here and say mass is 3 kilograms and acceleration is negative 36 sine of 3ti minus 72 cos of 3t of j. But remember that your r initially, R was 4 sine, I think 3t I plus, was it 8 cos of 3t j? I think that was our R. Now, what does it mean? You're going to ask yourself, how can, this was a plus and a plus. So this is your R, meaning you must create a plus. Here, you must create a plus and a plus. Then number 2, how can we create a 4 and 8? You ask, what is common in 36 and 72? What is that common factor? Can you put it in the chat in case you have seen? What are we going to factor out? Because now we need to factor out a negative, but also we must remain with 4 inside and 8 inside. So what is that digit that we must factor out? Someone saying 9. Someone, Ochenga said 9. Very good. So if we had factored out 9, we shall come and say there is 3 times negative 9. So when I have factored out negative 9, meaning here I remain with 4 sine of 3ti plus 72 divided by 9. I think that is 8 cos 3t of j. So 3 times negative 9 will give us negative 27. When you look at what is inside our bracket here, is the same as R. And therefore, we shall say force is equal, this is R, and therefore, we shall have our force equaling to negative 27 R. So that is how you come to prove that your answer is very, very okay. So that is what they wanted us to prove, that that one holds. Okay. Okay. Let me hope we are still on the same page. Okay, negative 9. Okay. 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 If you have finished, you're going to allow me to stop sharing and I give you some work that you can try in your free time. So this for this UNEB we have done. So I'm going to share with you this work on vector calculus. So what you do, you're going to try out these numbers in your free time. You try out and see whether things are coming out. Yeah. And even now you can try out other numbers from the question bank that are almost in the same caliber, such that at least you can be able to prepare in case such a number comes, at least when you are in position to do it a bit better. Okay, so allow me that we end here, and I want to wish you a good evening and see you next time. Have a good day, everyone.